Hello everyone, I am Lalit Jain, Assistant Professor Electrical and Electronics Engineering Department of Oriental College of Technology, going to present combinational and sequential circuit concept. The logic circuits for digital systems are basically divided in two categories, the combinational circuit category and sequential circuit category. Further, the sequential circuits are divided in two other categories, asynchronous sequential circuit and synchronous sequential circuit. In case of asynchronous sequential circuits, we use latches as a memory element, while in case of synchronous sequential circuits, we use flip-flops as a memory elements. The combinational circuits are basically consist of logic gates whose output at any time are determined directly from the present combination of inputs. The combinational circuit does not have any kind of memory element. The combinational circuit has n number of input values while m number of output value. The one thing which we need to remember that combinational circuit is the combination of logic gate and it does not require any kind of memory element. As an example, adders, subtractors, binary multipliers, encoders, decoders, multiplexers, demultiplexers, code converters can be used as a combinational circuits. While in case of sequential circuit, the output of sequential circuit depends not only on the present input but also on the past input value. It has memory element in the form of latches or flip-flop. Basically, latches and flip-flop are 1-bit storage device. The sequential circuit also has n number of inputs and m number of outputs. Here you can see the basic building block diagram of sequential circuit, where it is going to use the combinational circuit and also one block of memory element as a latch or as a flip-flop. The sequential circuit examples are counters and registers, while the memory element can be used as a latch or flip-flop. Here you can see the combinational circuit versus sequential circuit. The difference is very much clear that in case of combinational circuit, the memory element is not present. Now the types of sequential circuit, if we are going to divide the asynchronous sequential circuit and the synchronous sequential circuit, then you can see in terms of history, the asynchronous sequential circuits were used with relays before the synchronous sequential circuits, while the synchronous sequential circuits were later introduced. Latches are used as a memory element in case of asynchronous sequential circuits, while flip-flops are used as a memory element in case of synchronous sequential circuits. More difficult because of timing problems involved in feedback path of latch. So the timing problem is taking place in case of asynchronous sequential circuits, while in case of synchronous sequential circuit, these are very less difficult since the timing problems are eliminated by triggering the flip-flops. As far as speed of operation is concerned, so especially in those cases where the digital system must respond quickly without having to wait for a clock pulse, so in that case we should use asynchronous sequential circuits, while the synchronous sequential circuits are used where the speed of operation is not much important. Now here you can see the basic difference between the flip-flop and latches. Flip-flop and latches, as I already told you, work as a memory element. These are 1-bit storage device. Flip-flop is basically used in synchronous sequential circuits, while latches are basically used in asynchronous sequential circuits. Flip-flops are basically clocked, while the latches are not clocked, these are unclocked. Flip-flops are age triggered, which are divided in two categories, either positive age triggered or negative age triggered, while the latches are label triggered. I will introduce what is the difference between age triggering and label triggering. Now the basic operation of these two, which we really need to understand while doing any kind of operation over the flip-flop and latches. In case of flip-flop, the output responds to the data at the inputs only on low to high or high to low transition of the clock signal. As you can see here, this is the clock which should be provided to the flip-flop when you want the response. The clock can be provided in two forms, either positive edge form or negative edge form. Whenever the edge, this vertical direction arrow is indicating the edge, in this particular waveform the arrow is indicating 0 to 1. In this particular waveform the arrow is indicating 1 to 0. So the 0 to 1 is basically going to describe the positive edge, and 1 to 0 is basically going to describe the negative edge. So whenever this particular edge of the clock comes, then only the output of the flip-flop changes. If the input of flip-flop is going to change between this edge and this edge, in between these two edges, if the number of time input changes, the output doesn't change. The output will only change when the edge comes. While in case of latches, the output responds to the data present at the input during the time the clock pulse level is high or low. That is, any changes at the input during the time the clock is active high or low are reflected at the output. So as you can see here, these red symbol is basically denoting the level. So levels are basically horizontal, okay, and edges are basically vertical as far as these diagrams are concerned, as you can see. So this top level is basically denoting the positive level of the latch, and this bottom level is basically denoting the negative level of the latch. So the one important point which we need to remember is that from this particular end to this particular end, let me take pointer so that it will be much more clear. From this end to this end, if the input of the latch is going to change multiple times, then the output will be changed. But in case of flip-flop, in between this edge and this edge, if the input of the flip-flop is going to change, then the output of the flip-flop will not change. Okay, that's why the flip-flop is called a synchronous device, while the latches are asynchronous device. So there are various kind of in fact four kind of flip-flops and latches are there. JK flip-flop is there, similarly JK latch are there, SR is there, T is there, and D is there. So JK is basically on the name of Jack Kilby scientist. SR stands for set reset flip-flop or set reset latch. T stands for toggle. D stands for delay or data. Fine. So this is all about the basic concept of sequential and combinational circuits. In the further class, we will take one by one the internal structure of latches and flip-flop.